Hey everyone, sorry I couldn't be there today. I had a quick phone call from my wife that my daughter was sick and my wife is working downtown on a legal deposition, so I had to go home right before school started today. So I just wanted to introduce one idea to you and then let you have the whole period to work on the second part of 10.1. Either look at the alternative examples for more examples with solutions on Schoology, or just try the homework and look at the answers at the back and then come in on Friday with any questions that you might have. A quick idea here. Yesterday, when we looked at Trump's approval rating from his 100th day to his first day and whether there was a change, we did a confidence interval, and I think we saw that there was a change of like 3% to 10%. Now, if we were doing a hypothesis test, we would start off with the null hypothesis, and remember that null means that there's no change, no difference. So we would say, oh, as a statistician, we don't think there's any difference in the presidential approval rating. So you would either say P100 equals P1, or the other way to write it is that P100 minus P1 is 0, that there would be no difference between the two. So in subtracting them, you would get no difference. 0 is going to commonly show up in our work because we believe in this idea of no difference. The alternative here might have been that his approval rating dropped, which would be that P100 is less than P1, or that P100 minus P1 would be negative, which we found out yesterday. Now, let me get to the tricky part. The tricky part is, what does the sampling distribution look like when we assume there is no difference in the population? Well, when we assume there's no difference in the population, then we put 0, that we believe that there's no difference in our samples, because the samples should be close to the population. Now, if we don't think that there's a difference between P100 and P1, and we don't think there's a difference in the samples, what we do is, instead of using P1 and P2 like we did yesterday, whenever you do a hypothesis test, we assume that the sample proportions are the same. And when we assume that, what we do is we combine or we pool the samples into one extremely large sample. For instance, one of the samples we had yesterday was 1,500 people, and it was like 38% and then 45%. I think I'm off by, it should be 675. But what we're going to do here is this p hat that shows up in the formula only for hypothesis test is the pooled or combined proportion that you would need to use, which is shown this way. You just put the two samples together to get a total of 3,000 people, and there's a total of like 1,240, it should say 45 successes. So when you see something about pooled or combined in tonight's homework, don't freak out about it. This is a little explanation of what it is, and I can answer more questions tomorrow. Good luck. I'll see you soon.